Imagine, if you will, a needle racing towards Earth at the speed of light. What would happen? Picture this: a needle, small and slender, the kind you'd find in any sewing kit. It doesn't seem like much, does it? But let's add a twist to our story. This needle isn't just falling, it's hurtling towards our planet at an unimaginable speed, the speed of light, to be precise. Now, the speed of light is a concept that's quite hard to grasp. It's approximately 299,792 kilometers per second. That's about 7.5 times around the Earth in just 1 second. Despite its small size, the needle carries enormous potential energy due to its speed. It's not the size or weight of the object that matters in this scenario. It's the incredible speed at which it's moving. So, we have a needle moving at the fastest speed possible in the universe. What happens next? Speed of light, a term you have heard but might not fully comprehend. Let's delve into it. Imagine light as a cosmic sprinter racing through the universe at a staggering 700 million miles per hour. That's fast enough to circle the Earth over 7 times in a single second. But why is light so fast? To answer that, we need to talk about a man you might have heard of, Albert Einstein, and his theory of relativity. Einstein proposed that the laws of physics are the same for all non-accelerating observers, and that the speed of light is the same no matter the speed at which the observer is traveling. This means no matter how fast you're going, light will always pass you at that same 700 million miles per hour. This leads us to a rather mind-boggling conclusion. Nothing with mass can achieve the speed of light. The faster an object travels, the heavier it gets. And to reach the speed of light, it would need infinite energy, which is impossible. But for the sake of our needle scenario, let's bend the rules a bit. Let's assume we've found a way to accelerate our needle to this immense speed, ignoring the laws of physics as we know them. This is purely hypothetical, of course, but it opens up a fascinating can of cosmic worms. So, why do we even care about light speed? Well, it's not just about being fast. Light speed is the universe's ultimate speed limit, and it plays a crucial role in everything from energy to time. It's the speed at which information travels, shaping our perception of the universe and our place within it. And even though we can't physically reach light speed, understanding it helps us comprehend the fundamental rules of the universe. It's a key piece of the cosmic puzzle, a rule that governs the interplay of space, time, and energy. So, with this understanding of light speed, let's return to our needle. A needle, small and light, moving at an unimaginable speed. What would its impact look like? Let's delve into that. In our world governed by the laws of physics, the energy of an object is directly proportional to its mass and the square of its speed. This is what we commonly refer to as kinetic energy. Now imagine a needle. Yes, a needle. Something so small and light, yet when it's moving at the speed of light, its kinetic energy becomes incredibly high. When this needle hits the Earth, all that kinetic energy has to go somewhere, right? And indeed it does. It's released upon impact, causing a massive explosion. You might be thinking, but it's just a needle. How big can the explosion really be? Well, to put it simply, it would be colossal. The exact size of the explosion would depend on a few variables, the exact speed of the needle and its weight. But given that we're talking about the speed of light here, we're looking at a potentially earth-shaking event. Let's visualize this a bit further. Picture the most powerful explosion that mankind has ever created, the detonation of a nuclear bomb. Now, imagine an explosion much larger than that. That's the kind of energy we're dealing with when a needle moves at the speed of light. But it's not just about the explosion itself. The impact would cause a shockwave that would ripple across the Earth, causing further destruction. Buildings would crumble, forests would be flattened, oceans would be displaced, causing tsunamis. The impact would be felt globally, not just at the point of impact. So, what does all this mean? Well, It means that something as small and seemingly insignificant as a needle has the potential to cause unimaginable destruction when moving at the speed of light. It's a testament to the immense power that speed can carry, and a sobering reminder of the force that light speed truly represents. So, an explosion would occur, but what would be the aftermath? Let's explore that in the next scene. A post-impact. What would be the state of our Earth? Now, that's a question that's been ticking in our minds, hasn't it? Let's delve into this hypothetical aftermath. The explosion resulting from a needle hitting Earth at light speed would likely cause a substantial crater. Picture that, a needle, something so minute, creating a lasting mark on the face of our planet. This crater would not just be a physical scar, but a reminder of the immense power of speed and mass. But it doesn't stop there. The explosion could potentially have wider effects, depending largely on the magnitude of the explosion. This could range from local destruction to a global catastrophe. Now, let's bring in the environmental perspective. The debris thrown into the atmosphere following the impact could have severe implications. The sudden influx of dust and particles could block sunlight, leading to a drop in temperatures worldwide. Yes, you heard that right. A needle moving at the speed of light could potentially trigger a new ice age. This scenario also brings to light the potential for climate change. The dust from the explosion could linger in the atmosphere for years, possibly even decades, altering weather patterns and disrupting ecosystems. In essence, the aftermath of such an event would be far-reaching, affecting not just the physical landscape, but also the climate and life on Earth. A single needle, then, could have a surprisingly large impact on our Earth. The power of speed, then, is not to be underestimated. We've journeyed through the realms of imagination and science, exploring the potential destruction a mere needle could cause. Traveling at the speed of light. This thought experiment underscores the immense power of speed, shedding light on the profound implications of objects moving at such velocities. So, next time you see a tiny needle, remember, it's not the size that counts, it's the speed. If you liked this video, don't forget to subscribe, share, and drop a comment. Stay curious and keep exploring.